Hey everyone, I've had a few people message me today asking what the heck happened in Beirut and what could cause an explosion like that isn't a bomb. Uh, Unfortunately, it's another case of a compound called ammonium nitrate, or NH4NO3. This, when stored incorrectly and sort of step by step of very poor planning happens, you can get an explosion. It's normally used as a fertilizer and can be used as an explosive. Two of the biggest non-nuclear explosions in history were both caused by ammonium nitrate. Once in Texas, the Texas City disaster, where 2,000 tons detonated on board a ship. I think the initial estimates in Beirut is 2,700 tons, so it could very well be one of the biggest explosions, non-nuclear explosions ever, right in the middle of the city, which is always hand. It was also used by a guy by the name of Timothy McVeigh. He created basically a bomb in his van, parked it underneath the federal building, and he had 2 tons of ammonium nitrate, and that was enough to take out a 10-story building and kill hundreds of people inside it. So you don't need a lot of this stuff to make a massive explosion. And you don't have to set it off intentionally. I'm not here to, I guess, comment on what caused it, or what may have caused it. The initial, so whether somebody set it on fire, whether it was an accidental fire, whether it was contamination, I'm not really concerned with that. I'm just saying what could happen in this horror chain of events that has occurred. So why is it so dangerous? So if we look at the chemical structure of ammonium nitrate, this guy is the worry. Oxygen. When you heat ammonium nitrate with a low amount of heat, you produce water. If you've seen the video, you'll see the color of the smoke. It's like a horrible yellow, orange, burnt, rust kind of color, and that is from the presence of N2O. And that's fine. And this, if you get to this fire, if the ammonium nitrate is burning, and you get to it whilst it's still in this stage, whilst it's only producing this, then you can put the fire out. Take a lot of water and a lot of time, but you can put the fire out. Now this chain of events and this chain reaction, the more heat you have inside this, wherever they were stored in tanks, they were stored in barrels, or in a warehouse that was sealed, or should have been sealed, then the heat intensifies, and then once it gets to a certain point, the ammonium nitrate then breaks down into nitrogen, oxygen, and now this is the point of no return. This is the point where there wouldn't be enough water in the world that you could put on a fire. It took 2,700 tons. Once it hit this stage where it was producing its own oxygen, or was being oxidized by the fire, by the intense flame, once it gets to this point, there is no stopping. So, more heat produces more oxygen produces more heat, more oxygen. And it gets to a point where the flames, or the movement of the fire, is moving at about 100 miles per second. Or about, meters per second, not miles per second. Or about 220 kilometers per hour. Actually, that might be miles per hour. They use the American way, that's what I was researching. So meters per second to 220 kilometers an hour. That's fine. That's what the fire was doing initially. And then all of a sudden, you saw that massive explosion. And that was what we call detonation. So when it's at this speed, the chemical reaction is moving through the air at 100 meters per second. That's why the flames go up and down. When we get to a point of detonation, you get movements at 2,000 meters, should write in proper notation, meters per second. And that is why you saw that massive explosion and the shock wave that comes with it. It goes from 100 meters per second, all of a sudden you get this detonation reaction and it starts moving at 2,000 meters per second. And that's what causes the shock wave. It begins with a small shock wave, and unfortunately what happens is this pressure wave pushes the unburnt gases ahead of the fire. All of that gas there goes ahead of the fire, and it pushes it with such intensity and with such heat, there's so much heat behind it, that all of a sudden the atmosphere just starts to automatically ignite. It doesn't need any flames. You can see it in the explosion, or you might not be able to see it unless you slow it right down, but the air is actually igniting significantly further ahead of the fire, and that's why you get that absolutely massive shock wave and pressure wave. So yeah, I mean, I don't know what started it. I don't know if it was a person or if it was purely by accident, but if it was by accident, it was a massive failure on the behalf of whoever was storing it. Having that much ammonium nitrate anywhere, let alone next to a dock in the city, is just waiting for something bad to happen. Thank you.